Hey guys. So, I guess you guys have heard like a whole heap of like optimization talk today, and interestingly, I've heard the word genetics and DNA profiling used a few times, right? So, I was going to tell you a little bit about my own story in my previous career, which was that as an Olympic athlete running the 400 meters for Great Britain. And what I do now, which is as one of the founding team and head of product for a personal genetics company focused specifically on fitness and nutrition called DNAfit. Now, if we go back 30 years, we would have given this advice. If you'd ask your trainer, if you'd ask the coach, like, hey, I want to be healthy, I want to eat better, I want to work out, they'd say, okay, don't eat any fat, but eat lots of grains. And then they'd say, okay, and go for a long sort of steady state exercise like jogging was kind of all the rage, right? So the advice is quite different than what we would see today. So if we sort of fast forward sort of 30, 34 years to now, we're getting told, hey, okay, actually, if you want to be healthy, eat lots of fat, don't eat any grains, and actually do like really short, high intensity, hard workouts. So there's this whole spectrum of advice that's completely shifted and completely changed. And it's kind of really complicated. It's really confusing for the end user to understand, like, what do they actually do? And actually, it's not even 30 years ago. It's probably like 10 years ago that people would still be saying, hey, actually, yeah, go and run for miles or go and do this. So the question is one of these right? Is one of those methodologies wrong? Are both right? Are both wrong? There's a very sort of confusing spectrum of advice. And we know from person to person, from like individual to individual, that we actually see very individualized responses to the same thing. If everybody here in this room did the same workout plan for 8 weeks, and we all started at the same point, would we all progress at the same rate? Would we all see the same sort of outcome if we all ate the same food every day for 8 weeks? The chances are not. We know we're individual. So let me sort of illustrate that individualism, that need for personalization through my own story and my career. So I spent about 12 years competing professionally in track and field, in athletics, running the 400 meters and the 4x400 meter relay. Has anyone here ever ran a 400 meters? Anyone had the misfortune of running a 400 meters? All right, so it's pretty hard, right, if you know about it. So it's a unique event because it's a sprint, but it's a very long sprint. So you need to be kind of an elite sprinter and an elite middle distance athlete at the same time to get there. And even in this very niche piece of activity, this very top-end specific task, there's a whole spectrum of advice, just like in losing weight or being fit. There's some people that would like to train like sprinters, do lots of short sprint stuff, and then put some endurance training on top of that. Or there's some people that like to train like endurance athletes, so do lots of mileage, lots of long stuff, and then put some sprint training on top of that. So there's kind of two schools. I'm going to show you a video of a race of mine from the Beijing Olympic Games in 2008. And just bear in mind those two methods, right? The sprint method or the endurance method, the power or the endurance method. And have a think about, from this race, which of those methods I might have used in the run-up to this, right? So if we could play that video, please. So I'm out to the far right in a white vest, getting overtaken by the guy in blue. So I'm there, third from the left. And if you could hear the commentary, they're sort of saying, Andrew Steele's not doing very well here. He's really struggling. He's going to have to pull something out. He's going to have to really get on top of his running here to get through to the next round. So this is in my first Olympic Games. And it was like a big, big moment for me. And I'd gotten there through a certain process. So think about this sprint or endurance. I got overtaken at the start. This is coming into the home straight. If there was commentary, it would feel a bit more dramatic. But let's presume like, oh my God, this is amazing. Andrew Steele is crossing the line. Oh, that's an amazing time. Yeah, amazing, right. Still applause. 10 years after the race. So still getting applause 10 years after the race, still feeding off that one glory of mine, which was the opening round of the Beijing Olympic Games, right? So that's fine with the video, thanks. So as you can see there was what do you guys think? Was I a sprinter or the endurance method? Endurance. Okay, so I guess you say that because I was pretty poor at the start, but I was kind of better at the end, right? I was like, I was slow out of the blocks, this getting up to speed, the acceleration phase. I was pretty rubbish at. I was pretty bad. But I could hold on to that pace for a lot longer. So I did that, and actually I trained like that way. I'm from Manchester in the north of England. We're kind of salt of the earth, old school coach who would just say, yeah, we'll go and run, lads, and he'd smoke 40 cigarettes a day, and say, we'll do more and more mileage, more laps, more laps. But at the top level, that's very rare. The average advice is to say, no, you should be a sprinter first. So after Beijing, I made some changes, and this slide tells you what happened. So I had London 2012 on the horizon, the biggest thing possible in my career, the home Olympic Games, and actually, I'll show you the difference between that race and a race 4 years later, the last race for the qualification for London 2012. I was not quite looking as in control as I did at the time, right? And incidentally, this race on the right was exactly 1 second slower than the race that I ran in 2008. So instead, this training changed to the correct way, to the sprint method that everybody else does, the considered good way to train for Elite 400, didn't work for me. And I found out the hard way through 8 years of trial and error. 4 years to Beijing, 4 years to London. Coincidentally, the Beijing race actually became better last year because I was upgraded from 4th place to 3rd in the relay when the Russians were disqualified for a doping infringement. So I actually won an Olympic medal for that race 9 years after I ran the race. So the story kind of makes even more sense now, right? But I found out a few pieces of information later on in my career when I discovered the role of genetics in exercise response, the role of how we're born affecting how we react to what we do. And I'm going to give you one example here. And there's a gene called the ACTN3 gene. And with every gene, you can have 3 versions of that gene. That's called your genotype. And it's communicated by a couple of letters. So in this case, there's a CC version of the gene, a TT version of the gene, or one of each, CT. And almost every Olympic sprinter ever genotyped has the CC or CT version of this gene. And this gene is responsible for really efficiently growing fast-twitch muscle fiber, sprinters' muscle fiber. And as you can see, I was the odd one out. I was in that 1% of Olympic athletes who don't have this gene. So by default, the way I responded to that sprint training, to the average way, was of course different. So it's a case of saying, well, the average advice is fine if you're the average. If you're not the average, how might we deviate from that? And the only way I could find out at the time was through 8 years of long trial and error, right? So there's a risk in following the average advice. So why am I faster than you guys? Now, one day I'm going to get caught out, and there'll be somebody in the audience who did run faster than me at 400 meters, right? So is it because I just did more training? Is it if you guys did the same amount of training, would you have been as fast as me? Let me give you a sort of another example. It's kind of the interaction between how we're born on nature, the cards we're dealt at birth, and what we do that makes us who we are. And that goes from nutrition to fitness to medical risks to all sorts of spectrum. And if we talk about performance and fitness, actually the way we're born and what we do are an interaction. It's not nature or nurture, it's always both. So if this lady here had all the genes you want to be an Olympic sprinter, she had the best Olympic sprint genes I've ever seen, she's probably not going to be a great Olympic sprinter because of her environment, her nurture. She's no track, she doesn't care about athletics. Whereas these guys in Jamaica, where people quit playing soccer to become 100-meter runners, even if they've got less of that nature part, the nurture is so optimum that they're able to sort of get towards that goal. So it's this interaction. And it's in that interaction where what we do at DNAfit comes in. So we're saying in general health and well-being is that we are all different. We know we're different, but yet we're given the same advice, whether that's the recommended daily allowances of certain vitamins, whether that's, hey, you should all not eat carbs anymore, or all eat a little bit of carbs and lots of fat, all do this kind of exercise, this is the sort of considered correct way, is actually we are all very different, and maybe we need to similarly deviate from that average advice. So how do we sort of take that into account? How do we make use of that? I'm going to give you a quick example of another gene. So we currently say to people, hey, fat's not really the enemy anymore. Grains are the enemy. Carbs are the enemy. And there's a gene, which is the most researched gene around response to fat intake and obesity. It has a link to type 2 diabetes risk. there's a gene with there, similar to the Olympic sprint gene we talked about before, the FTO gene. And in this study, which was on 23,000 people, they split them out by genotype, and when they looked at their fat intake, and they increased their fat intake over a period of years. But as you can see here, guys with the AT or TT version of that gene, very well. The advice on fat intake now saying, hey, don't worry so much about your fat intake, might be fine. But guys with the AA version still saw their body fat increase with increased fat intake. So the question is, how do we take that into account still to say, well, the average advice is fine, but if you've got the AA version of this gene, perhaps it's not quite as fine as it would be for somebody with a different genotype. Just as a sort of further example, one of the most confusing elements of nutrition, if you follow the media and sort of latest research, is caffeine. It's coffee. What do we do with this? Because people say 1 week, this is really good for you, drink loads of coffee, you won't die. Next week, caffeine's associated with early death. So it's really, really confusing how we do this. So again, there's an individualization factor. There's a personalization factor to this. So there's a gene called the CYP1A2 gene, and it controls about 95% of caffeine metabolism in the liver, the enzyme that it creates. And with this gene, you either have what's called the fast metabolism version of that gene, or you don't. You're a slow metabolizer. There's no middle ground. But naturally, when they've set the guidelines, and the average guidelines say, drink 2 to 3 cups of coffee a day and there's no increased health risk. Above that, there is. So if you took 1,000 people, and 50% of them were fast metabolizers and 50% are slow metabolizers, and you wanted to set an average guideline, you put the guideline right down the middle. But there's no middle gene. You either have the fast version or you don't. And so interestingly, in this study where they looked at actually risk of heart attack from caffeine consumption, and if you took just the average guidelines make sense. 2 to 3 cups of coffee a day, relative risk in the top left there is marginally higher at 2 to 3, but it's only when they go 4 and above that actually that risk increases. However, if you then split them out by genotype to fast metabolizers in the bottom left and slow metabolizers in the bottom right, you can see that fast metabolizers, happy days, just drink all the coffee, guys, that's fine. If you're a slow metabolizer, even the average guidelines of 2 to 3 cups of coffee a day are increasing your relative risk. So there's a need to understand this, not just in an element of, hey, can I get bigger muscles? Can I run the 400 meters faster? But actually, can I improve my long-term health in a preventative way? So it really brings into sort of what we created, and we're about 5 years old now, and what we did was try to make this super easy and super accessible to anyone. And we do a home DNA kit. It's a simple buccal swab, like a cotton bud on the end of a stick that you rub on the inside of your cheek and send back in the mail. And from that, we report on about 50 or so genetic variants that are the most researched, the absolute sort of tip of the iceberg when it comes to response to exercise and response to nutrition. So we look at things like training intensity response. We look at things like injury predisposition and recovery speed. And then we look at lactose intolerance, caffeine metabolism, response to carbs, response to fats, whether you might need more of certain micronutrients than the next person or the average. And so we just try to give that sort of overall personalization picture of how your genetics impact your environment, or how they should impact your environment. We don't know the whole picture. Genetics is only one very small part of the picture, from your preferences, other biometric markers, your environment in which you live, but it is a factor. And up until now, we've been very good at measuring those variable factors, measuring our weight, measuring our heart rate, measuring our steps, but we've only made assumptions on the static part of that equation, on our genetics, and said, I think I respond better to that, I think I'm made this way. So all we're doing is providing a light shone on that static part, the nature part. And we do that and create these online portals. We've got a sort of training plan system where we can impart sort of personalization and a meal planning system as well, and sort of in-depth interactive reports and a chat with our coaches and nutritionists. So it's really this home, this ecosystem of personalization. But there's a challenge here. It's very exciting, and a lot of people are talking about genetics even today. But how does one validate or know that what you're sort of giving the end user is worthwhile in an unregulated space, in the wellness, lifestyle, genetic space? So we put in an inclusion protocol which just says that we need to make sure that there is a consensus of multiple published peer-reviewed studies linking every genetic variant to the trait in which we report it, that we only count human studies, of course. Sounds common sense, but you'd be surprised. And then lastly, there's something you can do about it. There is no bad news. There is only stuff that you can change, lifestyle factors. And we put that further, just last sort of context for you. In 2016, we published the world's first ever sort of genetically guided exercise intervention study where we looked at, can genetics get you better quicker? And effectively, we showed that. So we did a series of performance tests with a genetically matched group, a genetically mismatched group, and the matched group had almost threefold improvement across both their performance tests in the same period of time. So really, it's a home of sort of what can we do to help you understand how you're an individual, to empower you to make individualized decisions about you rather than just what your friend did or what you recently read in the paper, all with the aim of sort of bringing around a sort of behavioral environment change that you can stick to in a sustainable manner. So I'll be around afterwards, guys. As you can see, it's a really sort of exciting industry. A lot of people talking about it. You might know how to train for 400 meters better now, but hopefully you'll understand sort of the need and the role of how personal genetic data plays a big factor in how we achieve our goal, whether that's just eating a bit better or if it's trying to win an Olympic medal in an elite event. So thank you so much.